Stanford University.
Welcome to EE380 Fall 2011-2012. I'm Andy Freeman. The other organizer of this lecture series is Dennis Allison, who is here today for some reason. Pound include administrivia. I'll get to it more next week. Today's talk has been revised a couple of times, so I think I've got what we're actually doing today. And we do appreciate the speaker for handling a bunch of problems that weren't his fault. And still coming up with two great talks. Two of the big technology trends that we've seen in the last few years are even bigger data and a return to shared computer services. Most talks and papers in this area deal with high-level concerns and enabling algorithms and that sort of cool stuff. However, the technology that actually makes it possible is, well, might be derogatorily referred to as plumbing. The problem with that is it's actually the technology that makes it work. Today's speaker, Pat Helland, is one of the few people, is one of the few people who have been involved in the guts of both kinds of systems.
Well, thank you very much. So, I'm Pat Helland, and I've spent a lot of years at Microsoft and Amazon and Tandem, and just recently, like 3 weeks ago, left Microsoft to move back to the Bay Area to be with grandkids. And so one of the challenges we dealt with was, do I get to present about the stuff I was working on in September, up and through September? Because normally you don't go out and present about products from inside your previous employer. And so I wrote this deck. This is slides that I wrote. And my colleagues or former colleagues couldn't make it today, and I got special permission to go ahead and do this. And I'm very proud to represent what I'm very proud of, okay? And so, and the first talk is called Cosmos, which is the product name, the internal product name, Big Data and Big Challenges. And one of my colleagues decided I was Microsoft expat, and so I thought that was a nice, cute way to put it. So what I want to walk through is I want to go through an introduction, give an overview of what Cosmos is, talk about a project that I architected and helped drive through, and by that I mean big ideas and working the compromises across the teams. I didn't code it, but I worked directly with the people who did, and it's called the Structured Streams Project, and then conclude. So first of all, what the heck is Cosmos? You haven't heard much about it. There's a couple of public papers that are a little bit old, right? But what it is it's a petabyte store and computation system. So we have literally several hundred petabytes of data spread across tens of thousands of computers, and there's a lot of data centers. And it is conscious on Microsoft's part and my part that this is vague, okay? That's kind of how it goes. But it's big. It's really big. Massively parallel processing based on Dryad. Now, Dryad is similar to MapReduce, but it lets you do a couple other things. You can represent arbitrary directed acyclic graphs of computation, and you functionally calculate things and feed things through, and if some portion of it croaks, you can restart it and all that kind of stuff. And we have automatic computational placement with the data. So it's like, oh, I got to run this piece of this directed acyclic graph of computation. Where the hell's the input? Where am I going to put the output? Oh, let's go do it over in this portion of the cluster. Scope stands for Structured Computation Optimized for Parallel Execution. Very few people on the Cosmos team know what the acronym stands for. But Scope is a language that is heavily based on SQL that it does set-oriented computations, very amenable to parallelism. And so you automatically compile Scope, and then you optimize it for execution over Dryad. And we'll see Scope is going to play a very important part in how we made even further optimizations in structured streams. Also, you have management of hundreds of virtual clusters for computation allocation. So this is a service. What does that mean? It means there's just lots of organizations that have contributed funding and want to use it to do stuff. And you have to manage who gets how much. Okay? And doing that in a sustainable, ongoing fashion is really interesting. So you kind of buy your machines. You actually, provide funding, and Cosmos gets the machines, right? And then you get guaranteed that much computing resources. But if you don't use it, somebody else wanting to use the cluster can slop over into using your stuff until you come along and then can bump them out of the way. And this is the source of great, confusion and complication. And it's a very, very interesting area of research. Now, what's essential about Cosmos is ubiquitous access to all of OSD's data. What is OSD? That is the Online Services Division within Microsoft, which includes Bing and a lot of other things like MSN and so forth, and the ads that are done on there. And so we have discovered, as have many people, that it is the ability to take data from God knows where you didn't plan it, and slice and dice and combine and look at it in ways you didn't think you were going to need to look at it, and then come up with stuff which is going to make you a ton of money. Okay? And we're not the only people who know that, but... Pardon me? What?
It's the unknown, dealing with the unknown.
It's dealing with the unknown, but putting it in one pile is really important. So, let's look at OSD and computation. Now, I tend to kind of be let's talk about a big picture, okay? And what you can look at is generally data comes in from the left and then users coming at it from the right. And so you have online web serving on the right. People are sending in search requests, they're doing things, right? And we're servicing those requests. And we're logging information about what they asked for and what they got. One of the big important reasons is the relevance calculations to figure out how to give them a better answer because they weren't too happy with the one they got because they had to look 5 pages down in the search results. So that's not good. So how do we get it to like the first page that they can do? So lots and lots and lots of data is generated every second that is then sent into the back end. Now the back end is running by crawling the web, getting feeds of other data from partners and so forth, doing ginormous batch systems, creating stuff which then influences the front end. So that's the big cycle that you see. Cosmos is that back end portion to almost 100%. There's a couple little exceptions, but that's the role of Cosmos, is doing that back end stuff. And so it doesn't really do the front end storage and computation. Now Cosmos is a service. So you have data driving search and advertising, web pages, links, all this kind of stuff. You have search logs. What did people look for? What did they click? What did they get? You have browse logs. What site did people visit? The browsing order. You have advertising logs. All that data is just as minor, it's just one subset of the stuff that is being shoved into Cosmos. Cosmos ingests or generates a couple of petabytes of data per day. Okay? Bing, MSN, Hotmail, client telemetry, web crawl snapshots, structured data feeds. And structured data feeds is like your partners are telling you, hey, I want you to sell stuff on Bing Shopping. Here's the product list. And it's structured in a format that then you have to crack according to your deal you've had with the way they fed it into you. And then there's a long tail of stuff. There's just lots and lots and lots of miscellany.
So given the controversy with Bing, you're collecting Google as well too?
The funny thing about that is that if you use IE, then the click information off of IE is part of the data that is being looked at. Okay. Now, Google did a great way of doing it. If you use IE to look at Google, then part of that information goes into Bing, and you can use that to influence what people think are popular results. And so that...
So 2 cookies are sent out.
One to Google, one to Microsoft.
No, I don't want to go down this if that's okay. I mean, we want to talk about, we can talk about that offline. It's
Yeah, no, I'm just curious because I was at the big launch by chance up in Redmond in Athens. So.
okay. And so, yeah, I understand. But it is the case that we're gathering telemetry on everything that we can in order to find out what people are happy with, what they're looking for. And that's how all successful search systems do it, is by looking at, I asked for this, and I got these results. How far down the results did I have to go to get to what I want? And so there's an enormous net of capturing knowledge that is involved in that. Does that make sense? Yeah. So Cosmos is that backbone for Bing analysis and relevance. Clickstream information comes from many sources. Queries are analyzed with user context and the success of them. And finally, it's a service. We don't put the code in a box and sell it to somebody. We really don't seriously let, with very tiny exceptions inside Microsoft, other people play with the code because we're too busy keeping it running and occasionally having a pager go off and just keeping the website up because it is a service providing value to online services division. So the Cosmos overview. From 100,000 feet, you can see the store layer on the bottom. Now the store layer is very, very similar to Google File System. So it's got the names are different, it's a complete different implementation, but if you are seeing it as similar, you are not confused, right? So we have extent nodes which run on every processor with very few exceptions in this ginormous cluster. They typically have 4 disk drives physically attached. We buy deliberately the crappiest stuff we can get. Now maybe that's not the right way to say it, but we work to optimize the cost of our hardware. And so consequently, we must be resilient to failures, right? And so there is a notion called an extent, which is very much like a GFS chunk, except it's variable length. And the variable length has some advantages, right? We can truncate it if we need to under failures. And then those are identified with a GUID, triple redundant, stored, triply redundant. There's all this plumbing which says, oh my God, I'm down to 2 of them, I lost this one, and then you better take one of the others and make a third, right? And if you're down to 1, it's all heck's breaking loose, you better get another 2, and that kind of thing. We scrub the disk. We're always reading the disk to make sure that it's still sane, otherwise the availability numbers wouldn't be correct. We compress it and recompress it later on to make it even tougher, right? All that happens within the extent node. There is a thing called CSM, the Cosmos Store Manager, which has a namespace. The names in the namespace refer to streams, which are byte streams of data with no structure initially. We'll talk about the changes to that, right? And then that maps to a set of extents automatically. So the application just sees it as a byte stream, and then it automatically finds all the stuff underneath that. On top of that, we have an execution layer. So jobs are queued up. I own a virtual cluster. I've got a certain chunk of my computation. Please go do this work. A job looks like a scope script combined with the input files and the output files, right? And when it starts, we come up with a job manager who's going to make sure that the scope stuff gets compiled, and then off of that, drive through where am I going to put processing nodes, where am I going to place them to be close to the data, how am I going to work through the stages of the computation so that I can create the outputs, to create the inputs, to create the results that I'm going to be making. Many processing nodes, host execution vertices running scope code. Inside scope, you can actually, pop out and do .NET code, and so you can, actually write C# things to do whatever your application wants to do, and then scope can talk about managing the parallel execution of that stuff. On top of that is the scope layer. So you submit scope code to the compiler. The optimizer makes decisions. I got a plan, I got some optimization, creates the algebra to feed down into the execution engine. So that's the 100,000-foot level of all the stuff that's in Cosmos. Now the store layer. It is comprised largely of 2 different pieces. The extent node, which runs on every machine, manages the physical disks, right? And it implements a file system holding those extents, right? And an extent is, it doesn't exist, you can append to it, you seal it, and it is immutable till hell freezes over and you delete it, right? That's all you get to do with an extent. It takes those and it compresses them, and then actually in the background compresses them even tougher, right? Spending more background energy to make them even squishier. And that's an important part of the EN doing all of that stuff. The compression is independent of the replicas, okay? So you're doing that on each independent machine separately. So the CSM, the Cosmos Store Manager, is a 7-way Paxos protected replicated manager. And so every serious thing it does, it starts talking to everybody else. And as long as 4 of them are up, life's pretty good, right? And that seems to be a pretty successful thing. We've had to deal with scaling by making many copies of the 7, which has been one of those fun things to deal with. And it instructs the replication of the extents across the various extent nodes. It handles streams. It handles the composition of streams out of extents. It talks about failure handling of how do I get a new extent, how do I close down the ones if I'm having a failure writing it, and it manages the namespace of the streams. The execution engine. It takes that plan. Here's the parallel execution I want. I want to run the scope job, and here's what the plan looks like with the algebra, right? And so scope compiler and optimizer gives it the algebra. Off it's going to find computers. It has to manage resources. It has to manage contention for resources. It has to manage physical placement of them. It has to manage the virtual cluster allocation of, hey, you only have this many high priority tokens, and so now what are we going to do with the low priority tokens if nobody else is using all of their high priority? And so it fires up, manages failures, drives restarts of failures of intermediate results, and makes sure this thing is done. Now, this is similar to MapReduce, okay? It's got, I could talk about some cool things in it and so forth, but it's very much in that genre of what happens there. Now, the scope language, again, is heavily influenced by SQL and relational algebra. So it's a little different in that you don't do update where, right? What you do is you have a set of stuff coming in, you do some set operations, and then you create a set of stuff going out. Now the way we've done that has been you extract out of an unstructured stream and you get a set of records which are coming in one at a time, and then you generate with a piece of your code whatever representation you want to do to put them out. And we'll talk more about that in a bit. So scope is a high-level declarative language for data manipulation, and the wonderful thing about it is it's designed to encourage parallelism. So the compiler and optimizer, it takes the code, and it creates the algebra, breaking the work into the processing units, the code to go into the processing units, and the description of the inputs and outputs. And a lot of those decisions about compiling and optimization are driven by data size and how do we minimize data movement. Historically, networking is a pain in the rear end in these kinds of clusters, right? And you have a heterogeneous network. Talking to this part of the cluster is a lot faster than talking to that part of the cluster. And it's an ongoing debate about whether that's going to get better. Okay, but right now, this is designed for a situation in which there's kind of a tight little funnel at the top of the tree, and talking to the other side is much more painful than talking to this side. Okay? Virtual cluster is a management tool. Allocates resources across groups, cost model captured in a queue and a priority queue. So a department may have a queue and it may say this is more important than that. And we're dealing with jobs that have to get done in a certain SLA. If this is not done in an hour, it costs us money. And people get pissed and phone calls get made and your manager gets annoyed at you and all of this kind of stuff. And so the virtual cluster has a guaranteed capacity and will bump other users of the virtual cluster's capacity if necessary. So if I go idle, you use some of my stuff, but now I want to go, you may lose your ability to use it. And then we have to throttle how quickly we bump them. Is that constructive? And how does that work? It's an ongoing issue of great research and great fun and tremendous opportunities for improvement that we've actually improved, and I know there's more opportunities there too, and it's a wonderful area. Okay, let me tell you about something near and dear to my heart, the Structured Streams project. So the idea was, we're running this stuff where we have records and we understand records, and now we're going to put them out in a stream where it's just a bunch of bytes. Right? And why did this happen? Well, because we started with streams, right? And then you just didn't, and then you put this other stuff up here, and then you never got around to making the plumbing understand what was stored in the data. Okay? So it turns out that by actually getting a little deeper and capturing that semantic knowledge and keeping it with the data itself, you can do optimizations that are, on the one hand, boring for a database person. On the other hand, when you look at how many thousands of computers it saves, they're pretty stinking interesting because of the parallelism that's involved. So Cosmos supports streams, unstructured, and you append to them. Structured streams are streams, but they describe the record format, they describe the ordering of the records within them, they describe the indexing so you can find a record by a primary key. Okay? That didn't exist before in the unstructured stream. Now, with structured streams also simplify the idea of an application having to write an extractor to crack the unstructured stream or an outputter to generate the unstructured stream, which was the way things worked up until this project, right? They offer performance improvements, right? Because you can have column features, you can have affinity management. You can say, I'm going to put the records of this stream, but I want them organized next to this other one that previously existed, because then I can join off of the same primary key, and the join is done in the same corners of the cluster. Okay? And then key-oriented features so you can look things up directly. So extractors before structured stream, you would come along, you would read the unstructured stream, you'd have a piece of app code or the standard one that you could just pick up, but if you just wanted to use the standard one, and then pull the data into scope. And the extractor would say, oh, I got a record, it's got this column, and it's got that column, it's got that column, one at a time it would be called in. And then when you would generate the output, you would put it back into a sequence of bytes and merrily discard the schema for it, okay? Because that's what you would do when you were starting with streams. And so the syntax looked like, I'm going to get my source out of an extractor, here's where the code is, and here's where the columns that I want to generate. And then I'm going to output the data from this data set, logical data set, into this stream. Now, it turns out, what we can do is we can walk up and we can look at a stream, and as we're generating the output, we can say, wait a second, scope, Cosmos, you keep track of how that data is stored. You do that. And so the outputter, if you look over here in the purple right here, it will generate stream D, which is an unstructured stream, or it can generate stream C and keep the metadata with it. And that metadata describes the record format, it describes the indexing, and it describes the affinitization and the partitioning of it. And so processing those queries with scope can ensure the metadata is output. And the representation of that stream on disk is in a format that is proprietary to Cosmos. But you don't need to know it. And it slightly simplifies your program because you don't have to worry about that extractor and outputter stuff. You just have to say, save it as a structured stream. Okay? Now, the metadata with streams and metadata and increased performance, by adding metadata into the stream, we can provide performance improvements. How do we do that? Cluster key access and partitioning and affinity are the big ones. So the metadata for a structured stream is then kept inside of it. This was an ongoing debate. How do we organize it? Do we have a separate metadata directory, or do we just stuff it in the thing that is sitting in the file system? And we chose the latter, and I think that's a more robust and simpler approach to getting it done. So with a clustered key lookup, it's pretty darn simple, right? We have an internal index. We come in with a key. We climb a tree, which is sort of like a B tree, except for it's pre-calculated, so it's simpler than that, right? And you can then find out where is the piece in the actual stream itself that you can go to look for the record. And because we write such large sequential output, we don't go directly to the record. We typically go to something about 2 to 4 megabytes within which one can search for the record. But that's because this is a ginormous sequential access system. How did we implement partitioning in Affinity? It turns out that joining streams can be very expensive, especially if you're joining them across the network on a large data set. So if you place the related data near each other, right? And so I have stuff which is, I've got the B's and the C's next to each other for 2 related streams, and the D's and the E's, I don't know where they are, but they're together, right, is the point behind this, right? And so you want to put data together and affinitize it when you believe it is likely it is going to be processed together. The whole idea behind generating a structured stream is to reduce the cost of the people processing the results of that structured stream. So it's the later job that gets the benefit, not this job, is the idea. And so if we want affinity, we create a partition as we create the structured stream. And we made mechanisms inside of Cosmos to understand how to associate that data with the same affinitization GUID and how to place that locally within each other. And you have each of the replicas has got different placement. And now you have to manage which replica placement do you have, because the replicas have to be across failure zones too. And then you can stitch together those pieces into one big stream, but the pieces, the extents, are placed in where they're going to be more efficient. So let's look at one case study, aggregation. I'm going to go to a domain, and I'm going to look within each domain in my entire ginormous set of the web, and I mean URL style domain, right? I'm going to look through the whole web, and I'm going to say, I'm going to apply some cost function to a domain, and then I'm going to find the top 100 out of the entire web, okay? And so how do I do that? Well, the way you would do it with unstructured data sets is you would have to sort, because you would have all the information about things and the domains are not necessarily together. So now you have to sort, which is really expensive. And then you take the partition, you do the partial aggregation, you push it back together, the full aggregation. That is super expensive. And you say, my God, why would anybody do that? Well, that's the MapReduce kind of approach to things. That's what we've been doing for a long time. That's how you get started in these ginormous stream processing systems, is you assume that things aren't organized and you have to then organize them in order to read them, right? Well, now it's a little different if it's structured. because it's much more efficient without shuffling the data. I can go through and I can look through each and find the top N within the domain because it's organized by domain. And so I can come up with that functional criteria of the top N, and then I just have to go through and figure out which are the top 100 out of that by taking each partition's 100 and finding them. Case study 2 is selection. I want to go get some stuff where the URL is www.imdb.com. So what did I have to do? I had to read everything and extract and filter and then union it. Well, I had to read everything. That's a pain in the rear. On the other hand, if I already have it organized by domain, this is so obvious to database people, they think we're boring, right? You know, that you look up where the partitioning is, you go to that one partition and you look for it. Well, and you would say, oh my God, that's it. Nobody's saying this is novel. What we're saying is, wow, this is, as far as I know, hasn't been done in these ginormous, you know, search environments where you're doing processing of massive amounts of data, number one. And number two, it really saved us a lot of computation, and it's really worth us building it, right? And so, I mean, I really think that it's made a huge difference, and so that makes it kind of interesting applying the database techniques. So what you do there is judiciously choose the partition, and you can actually push the predicate close to the partition. And so within the partition, now you can do a key range lookup, and you're much, much better off on 2 dimensions. There's a lot of savings in that. Okay, next is joining multiple data sets, right? So here I'm going to go through and I'm going to get a domain where the domain is www.shopping.com, and then I'm going to get this within it and that within it and combine them together. Well, what we used to have to do was go through the entire massive data set, finding anything that has to do with www.shopping.com, extract it, filter it, sort it, partition it, do a merge sort, get it back together, and then find the information and process the join of the thing. Well, it turns out that if you have web table and clickstream, and each of them is sorted by URL, what you could do is say, wait a second, I only have to go to the partition that's got shopping.com. And then I'm going to take the stuff and filter the stuff for shopping.com out of that one partition of W and the one partition of C. And by the way, they happen to be affinitized. Oh, gee, that means the join that happens is in the same corner of the cluster, and it's much, much faster. Okay, conclusion of this section. The takeaway is Cosmos manages the online services division's data and computation with hundreds of petabytes of data, many thousands of batch jobs every day, and tens of thousands of servers spread across lots of data centers. All the data in the same addressable store is essential to the business. We've been burned by this and then pleased by this, and there's clarity inside of Microsoft that if you make everybody able to address and access all the data, you will get wonderful, surprising results. And if you create silos of data, you will have pain, okay? Now that means it's an evolution to get everything into the same ginormous place, which is not a silo, and Cosmos is that for the online services division. Cosmos is evolving. So for example, structured streams allows large-scale parallelism with database techniques that do dramatically improve the efficiency of the computation. We are not telling you that the database techniques are brand new, but applying them this way is kind of cool, right? In the works, and this is something that I don't get to talk much about, is a project to do integrated random and sequential processing over the same data. So you can be doing ginormous batch stuff at the same time as you are randomly updating lots and lots and lots of changes. And that's even vaguer than the other vague things because I can't tell you anymore. But amazing amounts of transactional reads and writes and updates that are randomly changing stored data at the same time as you're able to sequentially process consistent snapshots of that. And so the transactionally correct changes over many petabytes of data is wonderful. Google's done some stuff like that with the percolator paper, and hats off to them. And it's a thing that's very, very interesting. Finally, Cosmos needs fresh blood. And I can give you contact information. I will strongly encourage you to send really interesting systems people to come and work on this because we will beat the snot out of them and they will get much stronger and it will be great for them and great for Cosmos. Okay? Yes?
One issue with affinity systems is it's rare that something that has affinity with only one thing.
Correct.
So who helps manage all the copies?
So manage all the copies, okay?
Yeah, if you've got something that needs to be in two places because it's got good affinity with two There's some
Well, first of all,
popular things.
This is simple in the following sense. Okay, you point at something and you say, I want to be like that. Okay, so something pre-existed, and you generate a structure stream. You say, yep, just like this guy. And so you can do a bunch of those. You can, make the next one and make the next one with another job, make the next one with another job. And to the best extent possible, that stuff, well, it will be labeled with the same affinity GUID for the various partitions that are there. And then to the best extent possible, Cosmos will attempt to push that into the same portions of the cluster. Now, it's allowed to not do that because it will be correct, but it will just be slower. And it is the application developer that needs to say, well, gee, I really believe I'm going to make data that's going to be useful with that data. So I am not trying to tell you this is the super optimized magic, gee, I don't have to worry about where my index is inside of a database, right? But I will tell you that doing that is, I don't know anybody who knows how to do that in a distributed system, right? And so we're giving relatively straightforward and easy to understand manual tools that have had a huge impact. But it's not, at one level, not the cutting edge of research. At the other level, it's like, damn, nobody's done that I know of, and it's pretty cool, and it helps a lot. Fair answer? Yep. Yes, from the back, and they'll come to.
I guess a related question. Do you have any numbers that show how effective this is? There's some people.
Well, even if I
claim
were
that
still employed by Microsoft, I wouldn't be able to tell you. Now that I'm not employed by Microsoft, I'm just going to sit here and smile. It helped a lot. And so,
Well, the answer is yes, they have numbers.
yeah.
That's right, they have numbers, yes.
Because
that
there's lots
Microsoft
of the
helps a
general
lot.
thinking that you don't know what queries you're going to have in advance because it's.
No, you don't know what queries you're going to have in advance, but you very, very typically know what data is related to what data. And as you develop an application, you have a pretty good idea that this data set is going to be processed in conjunction with that data set, and they're related to each other. And so a lot of times it's really useful.
So you know the queries that have been posed in the past.
You do know the queries that have been posed in the past, and that is a project that is being discussed to be able to actually look and analyze, and there's ongoing work to analyze what has been successful and what hasn't, and use that to influence the newly generated stuff. You're absolutely right. And the wonderful thing about this is that each of these optimizations is so successful in saving money that it allows for a feedback loop of investment, which is just a joy. Okay. Dennis, you had a question?
Do you guys use any of the probabilistic stream algorithms of the sort that were developed here at Stanford in the Streams project? These are things where instead of actually doing the sort, you get an answer which is equivalent to the sort to some probability.
We've discussed it, but that's not been what we've gone through, and it's really interesting stuff. And the people who understand that even better than most of the Cosmos team, who are systems people and plumbing people, are our dear friends who are right on the next floor, who we spend a ton of time with, who do the data mining, where they're going through and they're processing the logs and generating the data sets that are then useful for people to then go ask the questions. And they really understand sampling and probabilistic stuff. We're much closer to file system people or database people. It's like, oh, if I lose a byte, I'm a bad boy, right? And that's kind of in our blood, and I'm not saying that's right or wrong, but arguably it's a successful layering to have another team on top that is going probabilistic, but it's a great source of discussion.
You're right within 1 point. Or 0.9.
I'm probably right.
Right,
exactly. So perhaps we'll start the next talk and see if you guys find that interesting, because it's different. Right? Okay, so stop it. So this is a talk I wrote a few days ago, and this is just random thinking that I have, and let's see if I can make this thing go. Come on, talk to me. Stop it. I don't know, you'll decide. Okay? So this is a talk I gave yesterday at the High Performance Transaction System workshop. See, now my title is Freshly Moved to San Francisco and Shopping for a Job. And so that's what I wrote down for my title. And,
Yes.
and my affiliation, yes. And so let's see. This, and again, I gave this at the High Performance Transaction System workshop, and it's called Condos and Clouds, and it's thinking about cloud computing by looking at condominiums. Yeah. So, I'm going to do an introduction. I'm going to talk about the drive towards commonality in buildings. In this section, I promise not to talk about computers at all. I'm going to talk about a useful pattern for software as a service applications, multi-tenancy and the rules for making it work, or issues with the rules for making it work, and conclusion. So let's do an introduction. I live in a condo. Actually, I moved out of that one 2 weeks ago, okay? But I moved into a condo into San Francisco. And that's the one in Seattle. And great view, right? Absolutely wonderful. My ears would pop going home, right? And but I loved it. It was great, you know, right by the Pike Place Market, awesome. But not everybody wants to live in a condo. You know, my youngest kid is 35, so I don't have issues with schools and playgrounds and stuff like that. But it's not good for kids playing in the backyard, dogs running in the backyard, working on cabinetry in your garage, and I don't really have any desire to work on cabinetry in a garage, nor do I have any desire to have a garden, okay? So it depends upon who you are and what you are. But it has advantages, okay? There's common heating and air conditioning, and it just works. It works, right? I can turn on the hot water and I never run out of hot water. Someone else takes the trash out to the street. In that building, I would go right around the corner on my floor and there's big trash cans and they were, you know, I put something in it and tomorrow it's gone. It was just really cool. In the new one in San Francisco, I really like this because I pull this thing open, I throw some stuff down, and I laugh my ass off every time at the noise it makes. It's so much fun. Trash chutes are great, right? But it comes with a building engineer who fixes most things. So condos are for some people, including me. Sometimes it's really nice to outsource a bunch of hassles, but in exchange, you must live with constraints, okay? So what are the constraints in condos, in buildings, and what are the concierge services that you get in exchange for those constraints? Well, in housing, you get somebody in the lobby, and they'll make you reservations, they'll pick up your packages and dry cleaning, you can have a shared exercise and pool, you have shared engineering. It's awesome, right? But parking is annoying. It just can be really annoying. You got to watch the noise you make. Some pets, some no. It depends upon the issues. Barbecuing, the new one in San Francisco, I don't have a barbecue and I don't have access to a barbecue. Okay? Well, it's okay. I got a daughter and son-in-law who I moved to be close to, and my son-in-law barbecues. It's awesome. It's good. But not in San Francisco in the East Bay. Okay? Right? I can't do garage projects and I can't do gardening projects. So some of the constraints. Now, if I go to an office and I sign up for an office building in a shared office tower, right? I have shared bathrooms and lobby and coffeers and engineering and security and a whole bunch of stuff. But in exchange, I get fixed office layout, and I'm probably not allowed to sleep at work, and I probably can't bring my pets to work, and I may or may not have a dress code, depends upon where it is, right? And so there's issues that come with it in addition to the benefits. And if I go to a retail mall like Stanford Shopping Center or something, right, and I open up a store there, I don't have to worry about a lot of things. I don't have to worry about the big electrical, the plumbing, a lot of engineering stuff. I don't have to worry about parking is shared, common space is shared, I got security, big advantages. But at the same time, I have to have my store open when the mall's open, and I can't have it open when the mall's not. And they tell me what I can do with retail. I can't do some kinds of retail. I might not be able to have a hemp store, right? You know, and there's constraints that are put on me. And all of those issues are in there as I go for it. Now, the question that we're going to discuss are what are the constraints and concierge services available in cloud computing? I'm sharing infrastructure. I'm not on my own. I got to do things in a way that fit in. And what do I get for it, right? How can it make my life better? What do I have to give up? So let's look at the drive towards commonality in buildings. First of all, I want to say not everything fits the common story. Not everything is going to fit the shared cloud computing either in a second, right? But there are some buildings for which you don't have a cookie cutter, okay? And that would be steel yards and shipyards and IKEA stores and Home Depots, well, although a Lowe's could take it over, right? And there's fixed things that are there, Costco's, for example. And so you have to have custom-made structures for those. And everyone has unique requirements that mean you can't do just any old building. But there's other cases. We've got these industrial parks. You know those things you drive down and it's got a big garage door and it's got a little single-person doorway entry to a tiny little office, one bathroom, right? And inside there's these big walls that are just sheetrock. And God knows what they're doing. Maybe they're taking deliveries. Maybe they're doing light manufacturing. Maybe they're opened it up and turned it into a deli. Okay, that happens. Sometimes you see nail shops in there. But you can reuse these things, but they're built in advance, right? And so there's, sometimes specialized retail is in there. There's convergence in retail buildings. There's different types, There's retail strip malls, there's mega malls, there's grocery stores, but those are created and reused, right? Reuse of standardized retail space where many different companies can use the space. They come in, they make leasehold improvements. If the Stanford Shopping Center says, oh, I've got a space here, and Gap comes along and says, I'm going to lease that space, they get the bare walls, they get the electrical, they get a little bit of plumbing, they get the lights, and they have to make it be Gap. And they have to do it within the constraints of the shopping center. But it's a much, much lower burden project than starting from dirt and building a building. There's convergence in housing. Housing is about people. There's many forms, contains the stuff, the people. You have standardized door sizes, plumbing, electrical connections. Your stuff just works. You do realize that couches fit through standard doors. Why? Because if they don't, people take them back to the store. Okay, and now these standards have emerged, okay? And it's all part of this feedback loop in making it possible to have different kinds of housing and the stuff you use in the housing be compatible across those different kinds of housing. There's convergence in office space, right? Because office space is about people moving in and doing things and talking to other people and doing work online and that kind of stuff. Building requirements are a standardized need for coffee machines and restrooms and copiers. But you see that standardization even if it's in a skyscraper, even if it's in a suburban edge city where you can't go above 2 stories. Right? What's going on here is you're outsourcing the site and the structure and the skin and the building infrastructure, but you can customize the space plan and stuff within constraints. So there is a drive towards commonality in buildings. What do I mean by that? Buildings are more typically created without knowing who will use them than the opposite. That is more common nowadays than the opposite. It's true with industrial parks, retail, offices, and housing. Each has standard specifications for the occupants. Because it's created in advance, they tell you what you can do with it, right? And that makes it work, right? So the new occupants have to fit into the space. And the custom buildings exist and will exist forever, I believe. They may get less and less common, but they're going to exist forever. So buildings are created without knowing who will use them. So now, let's talk about software as a service. So many services fit a pattern, right? So what's the pattern? A request comes in, you fire up and hook up to a service. You may or may not go get some state. Okay, but you didn't have the state when you first got the request. You had something that let you go get the state, right? And then you may or may not call somebody else to go do some stuff. And you may or may not go look in a data cache of some interesting things like a product catalog or a price list or something like that. And now you come up with what the user wants and you give back a response. Okay? This pattern happens over and over and over when you have software as a service. And that allows for outsourcing of many hassles. And I argue it's a lot like living in a condo with a building engineer. Okay? So what is the automagic dream of concierge services? I want to have auto scaling. Workload comes, pull in more servers, handle the workload. Resources are taken back when the load drops. I want to have auto placement. I don't have to worry about where the things are running, the fault boundaries, the geographic transparency, all of that. Applications are just blissfully ignorant. They have programmed to an API describing the semantics of what they want to accomplish, and it works. Capacity planning. It's like, wow, we're on this trend. What do we think we're going to get? We ought to be able to just print out a report because the system ought to be smart enough to track your trend lines and tell you what the heck to expect. A resource marketplace. You need to know what it costs when you do this and figure out a way to trade off those costs. So many times in these systems, people do stuff and they have no idea you're just cremating the plumbing with a burden that it doesn't want to have, right? You have to have a way of costing that and giving proper feedback. You want to have A/B testing and experimentation. It's like, oh, gee, I think I'm going to do this. Well, let's go see if it screws the entire universe up, right? And you turn this thing on, you're in like 0.5% of your workload through it. And you say, oh, but no, I'm not going to do that, right? And then you pull it back, right? And that's a classic thing people do, but it's all done by hand in most environments. Auto caching and data distribution. So I want to be able to create those data sets which are used in the cache, and then I want to be able to manage the distribution of them automatically and make sure that they're there. Now the interesting things about that is typically not written by the front end stuff, it's written by the back end stuff which stuffs it, right, and integrating with that. And finally, session state management. So requests come in and out, multiple requests for the same session, whatever that means. How do I go back and get the stuff that I left, and how do I capture that stuff and put it away for the next time that I'm working on the session? So let's look at stateless request routing. Incoming requests are routed to one of the copies. On arrival, he doesn't know nothing. He just got the request, right? At this point, it's considered to be stateless, but it might get some state later. So what's the plumbing going to do? He's got a pool of servers, right? And he's doing load balancing, and he dynamically increases and decreases them. You've seen this thing, but it should be magic. Now, what do I do about this composite request processing? I got to call A, which is going to call B, which is going to call C. And this happens a lot. This happens a whole ton. You have no idea. You just, and one way to really get a sense for this is to just go to Amazon.com and issue a request and actually watch how the screen kind of jitters as it's painted. It's fascinating because it's all related to this kind of everybody's calling everybody. Yes?
Yeah, when they came and described that here, at the front page of Amazon, in the old instantiation, not the new one, had they basically touched 130 or 140 servers.
I think that's a conservative number.
And it is now. But
And I worked there 5 years ago, so I'm going to smile and say that it's a very interesting. It's wonderful technology, just wonderful. Okay.
Facebook claims over 500.
Oh, I would not be at all surprised if Facebook claiming fell over 500. This is normal. Now, the thing is, it's typically flat. We'll talk about that in a second. You try to flatten that tree. Well, that's coming up here in a second, okay? Now, the service has to know when to break cycles. You need to make sure your call graph is of a certain depth. And it would be nice to make this far easier for the application developer. I aspire to somebody who is interested in insurance, just not really understanding distributed systems, to be able to build software as a service for an insurance company. But this is not any different than the things I did in the 70s and 80s working on TP monitors, where the insurance programmer didn't need to understand multi-threading to deal with hundreds of terminals, right? It's the same kind of thing. This is what plumbers do, and I am proud to work in plumbing. I kind of like to stay away from the ceramic part of plumbing, but I love plumbing. Okay, so I was asked if it was okay to refer to me as a plumber, right? So SLAs and request steps, right? So does the service provide the level of service it promised? Is the response fast enough? So you need these system-wide SLAs, but those in turn need type component SLAs because of the multi-level call graph. And when I talk about SLA, I'm sure it's what the other guys like Amazon and stuff talk about. Typical example is I want to do 300 milliseconds response time for 99.9% of my requests with 500 requests per second. And you just don't talk about averages. If you talk about averages, you are a wuss, and you will fail, and you'll be replaced by someone who talks about percentiles, okay? Because it just, your composite response time rapidly gets unacceptable, okay? Cross-service dependencies, force tight SLAs. Again, average versus percentile. Average is not strict enough. So if I have a call graph like that, I want an SLA there, which means I need a tighter SLA there, and a tighter SLA there, and a tighter SLA there, a tighter SLA there. Okay, and down it goes, right? And it's a pain in the butt on the bottom of the stack. And that, pardon me? And no loops. You do not have loops, right? And that's how things work. And then you worry as the depth of the stack gets down there. And you worry as the breadth of the stack gets down there if everybody's dependent upon it. And that is why I talked about Amazon allowing answers before everything was there, right? Because that gives a better user experience. If your recommendations is a little slow, you're still looking at the product catalog answer, right? Which is a good user experience. So pounding on the services at the bottom. The deeper the call stack, the tighter. So consider the session state manager, the auto cache manager. They need to be really tough, right? And the deeper the call stack, the more pressure. How can you need to sacrifice utilization. Those guys at the bottom, you might not be running them at 90% utilization, because 90% utilization means it's 10 times the response time of your minimum response time, and the typical queuing theory stuff. So how are you going to provide the tight SLA? Is it a short minimum response time, a really low utilization, or both? And it's probably both, the deeper you get in the stack. So how can I do automatic provisioning? The plumbing knows the desired SLA for the services. The end user facing service. I argue that the programmer just should be able to put this is a dream, okay, should be able to put the SLA on the end user response. That then turns into a resource marketplace with costing associated to calculations of the utilization of the call stack depth and visibility to the programmers about what it's costing them and how they can do it. But man, you asked for this and we'll fire it on up for you, right? And we can make this work. Based on the demands of the calling service, a desired SLA can be calculated. I don't know that this can be fully automated, but I do believe over time it can be. I think we have to iterate towards this because this is where we should be to really make cloud computing work. So within limits, the SLA can be met by increasing the number of servers and then decreasing the utilization. And I don't think it's useful. It's useful most of the time, but not for everything because you have to get your minimum response time down too or you're already doomed, right? And so this is an interaction. I'm not claiming complete magic. I think we can get a lot of magic though, okay? So accessing data in state. When a request lands into a service, it doesn't have any state at first, but then you got to go fetch the application state, and you may fetch some cached data. And the interesting thing about that application data cache is it is read-only from the standpoint of the front end and stuffed from the back end. Okay? And that's the common pattern you see. So session state is fetched from the session manager using a session key. You whack on it, you change it, you push it back, and you can get it next time the session comes in. And the cache data is stuffed and then read-only by the other end. Now, the typical response time, I would argue, is sort of kind of 5 milliseconds response time for this stuff, maybe 10, but you should have a really good discussion here because this is at the bottom of the call stack, and sometimes people deep in the call stack want the session state, which is deep in the call stack, and so this can get pummeled. And so it's a serious design point to make it as fast as you can. Data publication and updates. The general model for data is the back end gets data from all sorts of places, feeds from partners, crawling the web, logs of what's going on and monitoring of the front end, just lots and lots and lots of sources. That data comes in, and then you run these ginormous batch jobs to process it. And then you say, okay, now I have this stuff, it's keyed by this key, and here's what you get when you come at it with this key. Right? And you know, Amazon, for example, comes in with their product identification thing, the Amazon Standard Identification Number, the ASIN, and then off of that you get all that nice description stuff you see, right? Somebody got to create that. Somebody's got to figure out how to push that out. Then there's got to be a whole bunch of caches to manage, and they've got to be really fast. If they're not, because a lot of people are asking information about that product catalog, and if they're not really fast, then all the people who ask are not really fast, and so that becomes a big issue. Okay, make sense to everybody? Okay, that's a useful pattern. And I did not get deeply into the back-end pattern, okay? But that's a very, very, very high-level sketch of the front-end pattern that I see. And I argue that pattern is sufficient for us to make things magic. That's part of the argument you're hearing so far, right? Now, multi-tenancy. Let's just wax poetic about some of the challenges of multi-tenancy, right? Landlords, management staff, keys, and privacy, okay? I have had the building engineer walk in when we weren't prepared, right? It's due to, you know, well, yeah, just bad. Okay, and so in rented apartments and owned condos or rented houses, the landlord or engineering staff will typically have a key to your home. They do so for good reasons. If there is a fire, if there is a flood, they need to get in there and do stuff, okay? It's important to have that in such a tightly, you know, together environment. And there's a well-established set of reasons that they may enter. And if they violate it, they can and should get into a world of shit. Okay? And there's legal issues associated with that. Renting or leasing a property, home, office, retail, light manufacturing, is a bi-directional trust relationship. The tenant is supposed to follow the rules, pay the rent, not trash the property, and not bug the neighbors, and a bunch of other things. Right? The landlord is supposed to give you access, keep the services going, and respect your privacy, right? Among a bunch of other things. Landlord-tenant laws took years to develop. I mean, there was just, you know, used to be the landlord would just kind of come barreling in, and this whole idea of privacy took time to get there. And so these are, do not want to post, you know, I'm going to postpone. Okay. Right. Landlord-tenant laws took time to establish. And they're complex when you're renting. It's even more complex when you have condominiums, right? And I've been involved with that, and it's kind of interesting. The shared ownership offers some very interesting things. And there's different laws and expectations for housing, retail, office. And it's okay that there's differences. There's differences for good reasons related to the usage pattern. Common carriers, protecting the provider and the consumer. So what is a common carrier? Well, the early common carrier stuff was largely related to railroads, okay? And the railroads at some point were told, no, you can't charge your friends less. Okay, why? Because you're doing things in a public fashion and here's the rules, right? And so that's one aspect of it, right? And so it was applied first to railroads, later to telephone companies, and I know ISPs are fighting it tooth and nail, and there's a whole ton of stuff related to common carrier law that's really interesting. Some interesting things are pricing not being differentiated, and protection for customers with common carriers with rules for privacy, safety, and care for their customers. If you go to a cloud computing provider, what goes wrong if they snoop at your data? Is there a law? How do you know? What's going to happen? Okay, used to be the landlord would come and snoop through your underwear drawers and stuff, you know, and then now they get in real trouble if they do that. Okay, and how are we thinking about that? There's also protection for the provider so that a common carrier doesn't get in a world of shit if something bad happens using their stuff that they didn't know anything about. There were real legal precedent battles with telephones. It was like gangster 1 calls up gangster 2, say, hey, let's go rob the bank. Okay, well, those guys, that telephone company, they helped in the robbing of the bank. Well, you laugh, but it took time to establish that that wasn't their fault. And we're not there in cloud computing, okay? We're not all the way there in establishing the laws, the rules, the conventions. The condominium laws of the United States define rights, responsibilities, and protections for developers, for owners of units, and for homeowners boards as you try to figure out how all this stuff comes together. I assert, without any justification other than big mouth and pretty PowerPoints, right, that we need clearer laws about rights, responsibilities, and protections for all the parties so that this can no longer be a friction point in using and establishing cloud computing environments. And let's talk about defining constraints and empowerment, right? Programming platforms define APIs, right? You want to use my platform, here's my API, right? And they have a model. They say, here's the way to think about your computing. You got to do it my way or the highway, right? If you want to do it with me, here's what you got to do. And different platforms have different usage models and expectations, right? Now, shared buildings have those expectations for usage. They typically are built without knowing who will occupy them. But they are built with an expectation of how they will be used and what's okay and what's not okay. You're not allowed to live and sleep in a retail store or an industrial park. You get in trouble. So now, if we're going to have software as a service, and I think we're doing great with some software as a service, I think we're doing great with infrastructure as a service. Gee, give me a VM, give me some files, right? But we're not doing great with platform as a service. We haven't really made that successful. If we're going to do that, we have to say, I'm building platform as a service for this pattern. Not for that stuff. You want to go do that? You want to do weather simulation? Don't come do my platform, right? Do it on your own, right? That's go, and it's fine if you do that, infrastructure as a service, but it won't work here. And so it's okay to address a large class of customers, but be useless for others. That's okay, right? We're designing it without knowing who will occupy it, but we're going to say, if you do it this way, oh my God, you're going to get all this cool stuff. So, conclusion. Automatic services, state and data. Apps using the plumbing without worrying about their business code. Session state, app data calls to others. Implement the business logic, and they don't worry about system issues. The app is busted into a couple of pieces. Back-end feed crawl processing, data from the feeds and so forth, and then the front-end web service, which we talked more about, right? Services awaken, fetch state, access the cache, do some stuff, give a response, okay? The plumbing prescribes how to access these services. This is the way you get it. If you don't like it, go use my competitor or do it yourself, right? Constrained application functionality so the plumbing can provide the support. And what do you get, I hope? Auto scaling, auto placement, capacity planning, resource management, A/B testing and experimentation, auto caching and data distribution, session state management. All these things can and should be concierge services you get just for signing up for the deal. Now, condos impose constraints. honest to God, I have a brother that raises pet chickens for eggs. And you know what? He doesn't live in a condo. And my condo doesn't allow pet chickens, and that's okay. Condo buildings are designed with expectation of patterns. People live with density, lifestyle, and so forth. You get all this good stuff. I mean, last place had wine storage. Wow, you go down, there's cold down here, and you get your wines out. And it's really kind of cool. It's the constraints that allow the community to exist. You get shared stuff, and they're based on sharing for reduced cost and increased benefits. If the constraints aren't right for you, condo living isn't right for you. If you want to raise chickens or horses or listen to crickets or work in your workshop or repair your automobiles, don't move into a condo. Okay? If the lifestyle fits it, condo living's great. I have no intention ever again to sweep a gutter. Never. Okay? Takeaways. Our relationship with buildings has undergone tremendous evolution. Housing, all these things are standardized. Standardization allows for outsourcing and sharing many aspects. There's efficiencies and flexibilities. But we had to change the usage patterns first, had to change the expectations and the laws first. Cloud computing is nascent. These new categories need help. So we're making great progress on infrastructure as a service. I mean, AWS is really an interesting product. It's really cool. And people love it for good reason, right? But it's in a different category. It's a lower level category. Platform as a service is poorly defined, like apartments, condos, office, and more. And what kinds of platform as a service would be offered? And how will they be used? And then how does that translate into automatic concierge services for that? Shared buildings became successful by constraining with usage and cleared laws. We have to define the constraints. We have to work on this. How do I constrain it? And we need new laws for rights and responsibilities for cloud computing. Cloud computing providers define regulations for SLA privacy security. The users have to have regulations for acceptable usage. So that's what I got for you today. We got about 15 minutes left for questions.
Thanks for a very interesting talk. I'm not sure that the condo analogy is going to hold up over the long run.
Well, I'm planning to live in one.
Yeah, no, you don't live in However, I feel funny living in one because I sign up for the Apple iCloud, right? And then all of a sudden I find that some of my information has been shipped off to Microsoft and some of it's been shipped off to Amazon, right? And so when I move into a condo, I don't imagine that my stuff is wandering off to these other locations. I thought that I signed up with this guy.
And so iCloud is a different kind of cloud. I mean, it's really cool, but it's just keeping data more than running applications, right? Is what I understand. I haven't looked at it closely. And I think it's a really interesting and useful thing. I don't know much about what they're doing for their back-end storage for it. I mean, there's interesting things as...
Some of it to Microsoft.
They ship some of it to Microsoft is fine. I mean, Netflix runs on top of AWS. The list goes on. But even more so, did they ship it to other countries you don't like? Did they ship it to other legal jurisdictions that may have access to it? If you're a European resident, did they ship it to the United States where it's subject to the Patriot Act? And so there you go, they're in it. And some of the issues we didn't discuss are blind subpoenas, okay? If I am in a condo and somebody wants to search it, I have a pretty good idea, at least after the fact, that they searched it. Okay, in cloud computing, if a search warrant is presented to the cloud...
Try a national security letter.
A national security letter and or search
Don't
warrant.
need a judge.
Fine. All the more reason why some people are legitimately concerned about the physical placement of their cloud data and the legal jurisdiction within which it goes. If the data passes over a piece of the internet through a country that you don't like, right? Or doesn't like you, what does that mean? Of course, that's a little easier to encrypt, and so that's a little bit less worrisome.
So is everybody going to have to start building data centers in Europe because they actually have laws about this?
Are the questions recorded okay? Yeah. So I think that's being done. Okay, and I think that's being done for exactly this reason. And so, but this is an example, one of many examples of where I'm stating that the laws and the constraints and the conventions and the expectations are not defined well enough for us to understand, for us to lubricate cloud computing to the extent that I hope it becomes lubricated. Is that, that's my assertion without gory details, right? Right. Yes?
It seems to me that, at least from your presentation, it wasn't clear to me how, if I bring my computation to your cloud, I must clearly rely on your infrastructure. It's not clear to me yet, from what you've said, how much I must rely on the behavior of the other people that are in the same cloud.
Your question is totally fair and right. And that's what I'm raising as a concern indirectly in the broader category of what are the rules, what are the conventions, and what are the expectations. Now, let me give you a specific answer to how I think the performance issues are going to be addressed, which is just one of the important characteristics. Okay, I believe how that's going to be addressed is with over-provisioning and prioritization. Okay, and so, look, if I used to say if I wanted to get home from Bellevue to Seattle, and I wanted to go across the lake to get home, and I wanted to give a guaranteed response to my wife, I needed a dedicated freeway lane. Period. That's it. No, that's what's being asked for. You want to guarantee, and let me tell you, fly-by-wire, right, and real time, true hard real time is dedicated capacity, right? And I don't think that's wrong. It's just expensive. And it is so expensive that it eliminates almost every usage pattern. I mean, I didn't say all, I said almost every, right? And where you pay for it, look, I want Boeing to do hard, real time in the flight control. I just do, okay? But most of us going for cloud computing.
Obama is seldomly slowed down by a traffic jam.
Pardon me?
Obama is seldomly slowed down by a traffic jam.
Yeah, he can be because of the mechanics of getting people out of the way, but you're absolutely right. You're totally right. And so now, what's going to happen? I'm going to sign up, I'm going to pay a certain price. My price is going to have an SLA. That's going to mean the cloud provider has to be able to look reasonably at the statistics of that. And they're going to have different pricing point for other consumers which are preemptible. Okay?
Yes. Well, that's resources, and that's a vital issue.
I said it's a subset.
There are other issues, like who stores on my data?
Ought to be that we have a mechanism by which we...
I hope so.
Yeah, exactly. No, yes, absolutely. We have to make that be your data and not somebody else's data. And arguably, this sort of kind of has been done even back in time-sharing days. I mean, I certainly spent a hell of a part of the period of time when I had hair. Pardon me? It was what?
Back then, actually.
It was in many ways better back then. And I also remember when the phone was wired to the goddamn wall, and it worked. But the phone was wired to the goddamn wall. I mean, you're right. And we're working on it. I mean, yes, but until we talk about it, start thinking about it, and pushing towards it, we're not going to get there. Yes?
It seems to me there's two pieces that you're putting forward. One was sort of the raising it as providing platform as a service, as well as the other one, which is this analogy to condos. And I guess the thing I'm wondering is, that question here is that the reality is we're on this trend where the hardware is getting cheaper and the software for running these sort of clouds is becoming more available, and that and a lot of this space, a lot of the cloud usage is actually for surge space, and that's because there's a lot of experimentation going on. So couldn't one hypothesize a world where we go more to the condo model, as in, I really literally buy us a physical space in a data center in the same way as you buy a condo, and I run data there, and so a lot of these things go away. The sort of data privacy issues go away, and it becomes down to the same.
I'm certain there will be a set.
It is somebody can't go into my cage without my permission.
I am. Pardon me?
Now.
We got that now, but I wonder if there's an argument that says that will be the
Look, there will be people who stay with that solution. That is more expensive than running in a fashion where you're sharing with others. And some people will pay the expense. And
if you want the guaranteed SLAs and not running at a reasonable utilization.
I hear what you're saying. Yeah, except for it's hard to run at a reasonable utilization when you have fluctuations, as almost everyone does. And so it's not...
Everybody has the same fluctuations because everybody hits the web at the same time.
No. I mean, retail peaks right before Christmas, and photo sharing peaks in January. right? There's a lot of things that are on different peaks, and it's essential to get that. And yet, and the diurnal patterns are there. There's a lot of ways that sharing allows for more cost-effective stuff. And when you couple it with preemptible, lower-cost things, you can get even more efficient utilization. Now, I want to come back and I want to reiterate that I believe you are correct and that it's a spectrum. Some people will have the cage, and some people will have the tight control, and they ain't going to trust jack about these sharing guys, okay? And some people are going to live in a house surrounded by 5 acres with shotguns, okay? And that's fine. It is fine. But other people, and I believe increasingly more people, will do things where they can figure out that it makes sense to share, to talk about the trade-offs associated with the constraints, and it is a huge place for us to innovate and invest and work to empower that. That's all I'm saying. Okay? Yes, in the back. Yes.
I'm wondering if we're going through a second iteration of these problems. So if you rewind to sort of late 90s, early this last decade, with with all sort of the physical infrastructure world around Exodus and other companies like that. So basically, you kind of evolved to a model where you started out with equipment on-prem. Then you had these sort of shared buildings with cages where you could bring your stuff.
Yep.
And then slowly you sort of evolve from there in the physical world to your data center provider offering you first like shared switching for the building, etc. And eventually some of them evolve to doing shared servers. And
So your point is that it's getting finer grained sharing.
Right, and then if you carry that out all the way to sort of an AWS type infrastructure as a service, now you got completely anonymized platform as a hardware.
And AWS is cool. You just got to eat your Wheaties before you write a program for it.
Right.
I mean, look, the guy who understands insurance in Java is, you want somebody who doesn't really know how to do a distributed system and how to deal with all these failures to be able to write their business app. That's what I'm asserting, right? They'll pay more money for that because they had to pay less money for developing the program. And then they can get better, enterprise integration out of it. They didn't have to roll their own from the VM up. That's all I'm arguing. Okay, Dennis?
So are you arguing for software subcomponents which are shared and are made available? So basically you have an instruction to look up a particular rate table for an insurance application?
Not strongly. I mean, I don't object to it, but it's orthogonal to what I'm arguing for. I mean, it's fine, and you can call it with a web service, and you could choose to do that. You end up, the granularity of the components in these things is typically coarser than that, okay? And so they typically talk about web services and services, and it's a different discipline of composition, related but different to the object style components.
So you're going for what amounts to a large scale granularity. Highly tied to a particular vertical application area.
That's what people build. Yeah, they get.
Sounds good to me.
That's what they do, and I just want to let them do it without worrying about a class of problems, and then we can worry about whether it's running on the same computers as the next guys and that kind of stuff. Right? Yes.
How do they not worry about it? Because Amazon fails, it has security problems. Google fails, they have security problems. I mean, the companies with all of the riches and resources of the world in technology fail.
Of course.
So how does a business app user, programmer,
Look, let's get realistic about the economics of it, okay? You start with applications that aren't that important. But you know what? They're a lot cheaper if I do this. It's a lot easier if I do this. But the risk in the business value isn't that big. And so you start building it out, and you start working it out. And eventually you establish trust, and eventually things happen. And everybody stubs their toes, and you clean it up, and you learn things, and you move on. And why do we trust the phone companies? Why?
That was the Facebook model until Facebook became embedded every place. And when Facebook failed, other real apps with real commerce and real economics started to fail.
I don't disagree with what you're saying, but it is still the case that the economic value of them taking the dependency was, in their judgment, worth the risk. Okay, and now then pardon me?
should have been if it wasn't.
Yeah, well, I mean, they made a choice. They made a choice.
It was
Either an
predictable that
ignorant,
Facebook eventually get flaky and so.
but it may have been an ignorant choice, but they made a choice. Okay, and I believe that those choices will be well informed more and more over time, and the providers will get better more and more over time, and we'll develop an ecosystem on it. That's all I'm trying to say. Yes.
Right now, we have two very low-level interfaces that it seems to me are not very scalable under this: key value store and SQL. How do we get out of this hole?
Well, key value store is reasonably scalable, and SQL is scalable within a single machine. I mean,
Build bigger machines.
but what goes on with actually what goes on?
Well, okay.
No, but
Scalable. That's, key value scores are not scalable because they're very low level. I mean, then you have to issue billions of.
But let me talk about that front end example I gave.
Okay.
I go to get my session state. I don't even know the stinking key. The plumbing knows the stinking key, and it goes and it finds it, but it stuffs it in a key value store somewhere. Okay? And somehow in my app, whatever I'm looking up in my reference data, my catalog stuff, I somehow am navigating through things that are indexed by key.
The key value.
It typically does. That's what happens right now.
That's what happens right now. Can we get out of this hole?
We can do it with some offloading of searching through it, but you can take and say, go find this by looking this up and going to do this, and some of that calculation can be pushed off into the plumbing, but it isn't going to be as slice them and dice them and fully flexible as SQL is, in my opinion. For one thing, SQL is value-based and assumes a flat environment. I think we need to have an identity and version-based management of this stuff, which is I'm looking for this thing with this identity, and then I want to go get that version of it, I'm going to point to it, and that's a different form of expression. And actually, it's one of the interesting tensions when you start getting into MapReduce kinds of scope, and Cosmos scope kinds of calculations. I'm working on a version of the data. And from that version of this data, I'm doing some thinking and I'm generating that version of that data, which is not quite the same as update where. Right? And so these are things that are still nascent. They are nascent, but we are gaining traction in there. Yes?
You started with the condo analogy, which has a relevant property, and the condos actually aren't scalable. You don't stuff 1,000 people into a condo.
No, but what you can do is you can
have
actually
1,000 condos.
look. Your ability to acquire housing is more dynamic with the standardization associated with it. Your ability to find office space is more dynamic with the standard. Yes,
but you're acquiring small units because because only 15.
And I'm arguing that with cloud computing too.
Right. But you're arguing also for the ability to easily construct scalable applications, and I will point out that the number of applications that actually have to scale is 5. It's a small number that we could sit down and list as maybe 10,000.
Okay, you can assert that, but I'm going to ignore you.
Most businesses never scale. Most applications never scale.
I don't disagree with you, and yet they're going to want to use resources and get stuffed off in the sky probably.
They're going to want to use resources, but
But
they
look,
all fit on a
when
single machine.
I picked a pattern with the generic statement of software as a service, okay. In general, those are you want to design that so that it can scale even if it doesn't scale, I would argue. If it's made easier, if it's an easy way to start out and say, hey, live with these rules, and if you get into trouble, we'll get you some more stuff and it'll just work. And so maybe that's just a bias that I have.
Yeah. Well, but I'll point out that there are examples of where people have almost done what you wanted, but they didn't try and solve the scaling problem. And that's Blogger, Tumblr, Yahoo Stores. I mean, Yahoo Stores is enormous, but each person's requirements are incredibly small.
I get it. I totally agree with you. I do. And some of what plumbing is about and what platforms are about is looking at patterns and deciding, oh, he did it this way, he did it that way, he did it that way, but there's a common theme and I'm going to provide my own way. It's not going to look anything like it, but it's carrying that common theme through. Now, you're absolutely right. There is a difference between the single scalable app and the scalable infrastructure for not so scalable apps.
Right.
I believe me, that's a phrase that I have used for a number of years now. Scalable infrastructure for not so scalable apps. I do, in fact, use it in a derogatory fashion usually, and I'll give you that. And that's a fair ongoing debate you have.
Yeah.
Okay.
There's a lot of money in both areas.
I don't disagree with you one bit. I do not disagree with you one bit.
And the advantage is one problem's a lot easier.
Yeah, well, come on, it's eat your Wheaties. Yes.
You made a number of law that has been developed for the relationships, be able to buy everything from a condo association agreement to a rental agreement to rent something. It took a long time to develop that. There's a lot of different bodies. What bodies, what processes, where do the rules for what you're talking about here need to be developed? How do we go about making that happen?
You have to follow the money. I mean, somebody has to decide they want to start providing these kinds of things and then start figuring out, okay, what does this mean and what's fair, and then pushing to get conventions first and then regulations later on. And that is not something I have great familiarity with because I'm a nerd, right? And I do plumbing. But I believe that we can get partway there without the laws and conventions, and then we'll get tangled up in some stuff. And then I think if that is a source of enough money, then it will get people interested and legislators interested. Just kind of, and I don't think this is a terribly shocking answer. It's just kind of how things work, right?
Forward and realizing that has to be done, one wonders whether or not there isn't another avenue to make it happen a little bit more rapidly.
Look, what's going to happen is there will be sharing and multi-tenancy for not so important stuff. That will create enough economic momentum to build the shared and multi-tenanted environments, right? And for people to use it. And then they're going to say, well, I'd use it except for this. I can't trust it for this. And that'll cause growth in its own right. That's what I believe. Yes?
So would you say that today's available cloud services, platforms, infrastructure, what have you, is best suited for not so important stuff? And if you had like really important stuff, you'd be a little careful about putting it on AWS, for example?
It depends. Okay, I would gladly store any encrypted data in any of the cloud providers.
Yes.
You know the keys.
Exactly, as long as I have the keys.
Right.
I mean, that's just a starter. That's just a starter.
And maybe a copy on another cloud someplace in case
Maybe,
that cloud fails?
absolutely, that may be. Okay, now, I mean, we're talking about trust in terms of privacy and so forth. I trust it, but you're absolutely, now you're getting availability with another cloud provider. I got it. I agree with you. I don't know how to do computation without trusting, okay? But let me come around this. Like, not very many of us have encrypted phone conversations. We pick the damn thing up and we talk. And we talk about stuff that we would just be appalled if were made public, right?
Actually, on the analog phones, that's true. Now, we use a digital phone. Every conversation is encrypted to the cell tower.
Yeah, well.
Yeah, but you think it doesn't get at the cell tower, rattle around the phone company's belly in a way where they could go snoopity snoop.
You don't have the keys to those calls.
You don't have the keys.
Exactly.
Right.
And so, but why do we trust them? We trust them because they get in deep shit if they listen. Yes.
You've neglected to observe how those laws and rules develop in the real world. In the condo case, building regulations and standardization occur because major disasters, major catastrophes.
I agree.
And so people are going to die before this.
Probably. Look, fire escapes took 100 ladies getting killed in New York. I don't disagree at some level, but it's not just people will die. Now I'm putting my cynicism hat on. Money will be lost.
Even worse.
Yes.
That's what I'm joking about. But you are right. But I'm just trying to say we're in this world where we're on the cusp of cloud computing. What's going on? Why? What is going to happen? And so you're not disagreeing with me. Just because I don't know how to change the laws doesn't mean I'm wrong. I mean, I'm a software guy. I'm not a lawyer. That you can trust me. Yes.
Privacy sort of issues that we need could be handled with contract laws compared to a criminal type law.
I'm not sure that whether they can be handled with contract laws completely, and in many ways those have to become standardized too, right? People have to come up with the standard forms of the contracts, and then something has to go wrong, and somebody has to get sued, and they say, oh shit, the next contract I'm going to write is going to have this clause. That hasn't been worked through. So you're right. I'm just saying we haven't figured out the relationship all the way. That's my big point. And I'm not going to argue the details, and I'm fine with what you just said, but I don't really know. I just know we can't figure out how to do this yet as a business all the way. Maybe.
Part of it.
Yes.
So over here, cloud services appear to be more popular than in Europe. In Europe, there are way more people living in apartments than over here.
Yes.
Any idea why that the inverse correlations happen?
I'm not sure. I'm not sure if there's a trust issue. I don't believe that there's a lot of cloud providers that are hosted in Europe. I think that the Europeans legitimately, and I'm not being critical, right, are more concerned with privacy than Americans, and Americans are more concerned with getting the next cool thing going on a whole, right? And
Maybe because they live in apartments and they know what's going to happen.
Having grown up in Europe, I would argue that the Europeans have informal rules. A lot of them are formal, some are informal.
yeah,
Like you don't
but
hang on the wall if you know that the neighbors,
Yeah.
you know it's legal, right?
but Americans have a little bit of a
Bang right back and say, sure.
look. On a whole, the American culture is derived from people who were insane enough to go to their own funeral and get on a boat, okay? And then insane enough to go march across the Great Plains to God knows what, okay? And that's a little bit in our culture, okay? And so I think, arguably, the reason the Europeans are far more reluctant to use cloud computing is because they're a little bit more risk averse in that way. And I'm not meaning that in a criticism. I mean, we're nuts, okay? And part of the reason that Americans are nuts and successful is because we can get out there and fail and call up the bankruptcy court and say, oh, shucky darn, doggone it, you know, all of my creditors are screwed. Let's go try again. And everybody says, wow, that guy he ran a startup. Don't say he completely screwed people out of millions of dollars. And so that's a difference in the culture and the risk taking. And I think that that's a big part of it is right now that's a risky proposition to use cloud computing and one with huge potential benefit and huge real benefit, but that's still scary. Do you guys disagree with this?
Actually, I have a historic example that relates to one earlier seminars, probably several years ago. We had talks about computer networks and whatever, and somebody was in a Silomar talk, I think.
I was at a
By a
Silomar today.
lawyer, I think. And he talked about the analogy between the ranchers and the herders. How do you set fences? How do you manage those fences? And some computer system, I forgot. Anybody here was there? Anyway, the point is have analogies between, I personally worked in analogies between how cities work and computer.
But dude, I want to talk to you more. I do cities and computer discussions all the
You
time.
should also talk to my colleague who actually gives the talks. Forrest Wortman. If you go back, and then it was at the E380 talk.
Okay.
And you can contact him.
Actually, you'd be interesting to talk to the guy we had here 2 weeks ago who used to work for EPRI, the Electric Power Research Institute.
Okay.
Because he literally came here pleading, it's like, can't you guys write better stuff? But we don't have to have heavy-duty security. And he just didn't have time to finish.
Well, they didn't have so far. Actually, they do need.
They needed so.
No,
They need it, but they just
Nobody
know about
wanted
it.
I've done many keynotes historically on in the 2004 to 2003 timeframe on looking at the history of urban development and how cities changed when the railroads arrived and how that's identical to what's going on in IT with the arrival of the internet. And so,
Translate almost anything you said to some historical context.
yeah.
Are there two books that you've written or read? One would be Christopher Alexander's The Pattern Language, which is very common.
I have not read it. I own
That's
it.
where Forrest came in.
And the other one is Stuart Brand's How Buildings Learn.
I worship it. I actually referred a colleague to it today.
I did yesterday as well. Myself, yeah.
Okay, and I have a presentation that these pictures, these sketches, came out of a presentation that was largely derived by exploring what he wrote about and comparing it to buildings and applications. But this was a different team than that, but yeah, slightly, but not.
Yeah.
Yeah, I love How Buildings Learn. I love it.
The talk that Forrest Worthman gave about this analogized the growth of cities to semiconductor structures. And there's an extensive set of slides, which was not made public because of copyright restrictions.
You
and
can
so
try to
forth.
talk him into giving you.
But I think
But it's different to do it casually.
He's local now for you, so
Okay.
you solved that problem.
I'm local.
Yeah, he's looking out for you.
Yeah. Yes, sir.
Otherwise, let me know that he knows me.
Okay.
So have you done anything especially different in the hardware? Are you using standard switches and standard racking? Have you done anything like what Facebook
You're
is?
talking about in Cosmos?
Yes, in Cosmos.
Okay. My boss, until 3 weeks ago, owned the team that would specify the hardware that was, the vast majority of the machines purchased for Microsoft that would be running OSD's stuff, and an attempt to keep it, standardized, but with versions as time goes on. And so, of course, you have to use the old stuff as it ages out and lives through its lifetime. I can't go into much details of that stuff. It is a wonderful area of interest, but, this is not something am at liberty to spend a bunch of time talk about, especially with the camera on, and so. But
We'll turn off the camera pretty soon here.
no, I understand. I mean, and
Oh, no, they're still on.
and there's this really interesting dynamic between how do you get networking is really very interesting area of, and it's a pain point for all of the people building these clusters out. And so the extent to which it impacts the software design is, I was talking about affinitization earlier. It's tough, man. If I had a flat cluster, I'd be a happy camper, right?
What cluster?
A flat cluster, meaning I can talk to the computer on the far side of the cluster with effectively the same latency as I can talk to the one immediately next to me. And a little difference doesn't matter, but it's like, don't make me think about it when I'm writing.
Of cores.
Right, unless what?
I call it the myth of cores. You know cores?
Yeah, well, I know that they're NUMA, but I also know that the granularity of interaction across a NUMA is much finer grained than the granularity of messaging in a cluster. And so I'm not, look, I built a NUMA machine when I was working with Dennis. I was chief architect of a CC NUMA machine, and that's where I learned that shared memory works great as long as you don't share memory. So
You got it.
But, pardon me?
That's Helland's law.
Yes, well, no, that's one of Helland's law is actually that computing is like Hubble's universe. Everything is getting farther away from everything else. I was working with you when I said that.
It's a corollary.
Pardon me?
What were the challenges, the problems with the network?
Everybody has, it's expensive. And so you have a hierarchy. And talking across the hierarchy is more expensive than talking close to it. And so you're going through a skinnier, that switch at the hub of the tree can't handle as much bandwidth as you're chattering back and forth here. And when you start chattering across there, then the queues start building up. Now, if it's an idle system, I could talk across that switch, and it doesn't matter. The latency doesn't matter. But if I'm queuing like crazy, it's horrific, right? And so now my batch job takes an infinite, way the hell longer if I haven't figured out how to have localization of the data being brought together. See what I mean? Yeah. Now, if I can over-provision that, if I could have a lot of network bandwidth, then I can just go, and it doesn't matter if there's a little bit of this and that. It's not going to really matter because I can talk to the other side, and it takes 10% longer than talking to this side. Screw it. That's fine. But if it takes, 1,000 times as long, I'm in deep doo-doo. It's fair enough?
Yeah. Did you ever find network problems create systems problems?
Did we ever? What? Yeah. Exactly. I mean, the whole thing is a system. I'm a little confused by your question.
Well, the complexity of the network, as the complexity scales, there are more things that can fail.
Nobody gets to the size of Cosmos without handling failures pretty gracefully. I mean, it's just what it is, right? It's like whack-a-mole with keeping the data, okay? You can walk up to a server and go, whoonk, and then the rest of the system goes, oh, and everything's replicated, and it's how fast can you whack it, right? And you can just keep doing that with individual servers, right? Now, what becomes challenging is making sure that things don't cause storms of interaction, which can then get in the way of latencies, which can then get people into retry loops, which can then cause you to cycle down the shitter, right? And you have to have enough slack in the system to allow that. That's not any different than having enough slack in 101 when you drive home, or 280. Okay, it's the same damn thing. There's not enough freeway capacity for everyone to leave work at the same time. It would be too expensive, right? Look, when the president gets shot, the telephones don't work.
But freeways are concrete and asphalt, and that doesn't fail. SFPs fail.
SFPs?
Transceivers, optical transceivers. #1 cause of failure in the network.
Okay, but you have another way. I mean, you don't have just one way to get to anything.
Yeah.
Okay, and so everything's going to fail. Everything, and so you got to have redundancy for everything. You know, the question is, does the system handle that redundancy well enough? And then what happens as you start getting to saturation points? That's when things are scary, right? Okay, that's when you need to figure out load shedding. That's when you need to figure out prioritization. And the problem is that people typically only learn that when they get burned, right? And it's just hard. You know, I do not critically point at any network, you know, software provider, any web provider when they have a problem. I mean, they're hard. These things are just hard. I'm interested in it and I'm sympathetic with them. And then if I look at the underlying reason and it was stupid, then I might be, you know, point a finger. But that's not typically the case because none of these big sites, it's very, very, very rare that they do something which is blatantly stupid. Am I making sense with that? Yeah. Don't know if I answered your question. You guys are like going way the hell over. But I'm having a great time, so I don't know. You know. I have to pull the plug?
I'm going to pull the plug on the and then say, if you were here, you could just hear all the good stuff that's going to happen now.
Oh, okay.
So
thank you.
Let's take your...
thank you.
For more, please visit us at stanford.edu.